Good evening, Sovereign Nation. My name is Will, and this is my entry into the Sovryn Hackathon. Today we're going to be talking about how to build a knowledge graph using Neo4j to map out all of the various transactions and all the activity in the Sovryn protocol, and we'll also look at how to use that to get all of the usage data and the swaps data and whatnot so that we can sort of more easily, get to the fun part, right? Get to the part where you can analyze the data. So the first thing I want to do, though, before we get into all that, is I want to motivate this project a little bit, right? So when I started looking at the Sovryn protocol, I wanted to, one, figure out how it worked, and two, I wanted to get my hands on the data and to be able to, just sort of do some of the data science and data analytics that you would expect to be able to do, which means I wanted to get it into a Python data frame. And there was no really good way to do this, right? So my journey began, like so many others, on the RSK Block Explorer, right? So I started to look up different transactions and whatnot, and I could see that, and it wasn't always clear as to what was going on, right? So this happens to be a transaction that involves the Sovryn protocol. I've been looking at this long enough to tell you that that's the Sovryn protocol address, but it's not clear what this is doing, and there's this strange information about topics. If we keep going down here, we see that some USDT is sent and transferred, and some wrapped Bitcoins are involved. RSK Explorer gives you this nice roll-up for the token transfers, so it will helpfully tell you that this is a token transfer, but it's even here, it's not quite clear. Okay, so some amount of wrapped Bitcoin was involved, and 3 tethers were involved. It's very difficult to get the lay of the land as to what's going on here. And it's also really difficult. It would be really difficult to get, let's say, all such transactions. What if you wanted every single transaction in which Tether was swapped for USDT that took place on the Sovryn AMM? Right? It'd be very hard to get that from the Block Explorer. So let's see if we can't find a slightly better way to do this now. So again, we're going to be building a Sovryn knowledge graph, and a knowledge graph is just, a graph in the graph theory sense of the word. There are nodes, and there are edges or relationships, and each one of those can be marked up with all kinds of helpful properties. And the program that we're going to use for this is called Neo4j. It's a graph database, but don't worry, you don't need to know any Neo4j to kind of follow along at home here. We're just going to go through this step by step. So the first thing that you need to do is you need to clone this project, and you're going to want to Docker compose up. So let's check out the Docker Compose file first. Here's a Docker Compose file. You can see it's just going to go and get the container that I built for this hackathon off of Docker Hub, and it's going to configure it all for you. This here is important. This shows you the default credentials. The default credentials are Neo4j is the user, and Stay Sovryn is the password. So let's go ahead and Docker Compose up. And this is just going to start, again, this is just going to start the one container, the one Neo4j container on your computer. All right. So while that's getting going here, we will see that we can access this on browser port 7474. So let's go do that now. Right. So here's my computer. It's port 7474, and you're going to be greeted with a screen like this. This is where you want to connect. You want to connect onto the same computer. So on your machine, this might say localhost here. And then 7687, Neo4j, and again, Stay Sovryn to connect. Fantastic. And let's just convince ourselves that we have great. So we have a bunch of nodes. We have the correct database. We're ready to move on. Let's take a little tour here. So there's 2 ways that we can get at the data in this knowledge graph. The first is by typing into the Neo4j Explorer. This is the sort of admin interface of your database. And we can also use a built-in tool that I created for this hackathon that lets you query it directly from Python, which is really nice. So first of all, let's just get some block data, right? So we will just there we go. All right, let's get some block data. So we can see that here. Again, you don't have to know Cypher to follow along. I'll sort of decrypt some of this for those of you who aren't familiar. But all this says is get the get the 10 highest block, or get the 10 lowest block numbers rather, right? So here we go. This is the very first, the very lowest block number. This is where it all began, right? Block 2742418 on the RSK sidechain. That's where it all began. Let's see the transaction at that block. So we'll go copy this sort of lengthy query here. We'll go here. You can paste it in here. And you get this nice little animation. So what is this? These are the nodes, and each of the nodes represents some piece of data, right? Usually the nodes are like nouns and the relationships are like verbs. So this is a block. So this is block indeed. 242 2742418, signed 2020 on 0930. And it contains this transaction. This transaction seems to have only one log event right here. And that log event is calling the Sovryn protocol. Fantastic. Let's see what's the deal with this. So let's highlight calls. We can see the name is ownership transferred. The new owner is this address, and the previous owner was null. So this is the creation. This is great. We've used the knowledge graph to find the creation of the protocol. This is where everything started. You can see that here. So that's fine. Like, that's great. That's a nice little proof of concept. We can show that we can do some IO with the system, but so what, right? Like, if we want to do DeFi with this, we want to chase the money. So let's start looking for some money. So we're going to query, and we're going to find just, some value, some transaction that actually has some value in BTC, right? Or in wrap BTC. So here's one. And you get this nice result object. You can, wrap BTC has 18 decimal points. So we can see that this transaction is worth about 1.8 Bitcoins. Fantastic. We also get the hash for this transaction. So let's dig into this hash. Let's see what this hash is all about. Now, I admit this is sort of a lengthy query, but it's fine. You can just copy it, come over here, paste it, run your query. And, oops, here we go. So we can start to see what in the world is going on here, right? So here is our transaction here in the middle. It has all these different log events here, right? And let's change how this looks slightly, okay? Some of them, of the log events, go to the Sovryn protocol. Some of them go to this loan token contract, or sorry, this loan token address. And some of them go to the wrap BTC address, right? So this is a loan. We can tell just by looking at this that this is a loan, right? Here, in fact, the name of this call is called mint, and it's going to the loan token. And the name of this is called transfer, and it's going to the loan token. So it's very clear, very intuitive, just by looking at this, what's going on. The loan token is being minted. So this person with address, right, 5D0EEAE, blah, 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 is getting a loan for 1.8 wrapped Bitcoins. Very cool. All right, so what, right? So now we've seen this as a sort of glorified block explorer. You can dig in, you can understand the protocol, you can see what's going on. But I promised sort of larger scale data analysis, right? So let's look at some of that. And as a demonstration here, let's get the swap data, the historical swap data, right? Now, for the purposes of this demo, I'm sort of skipping a bunch. I'm limiting the amount of data I'm getting. But if you really wanted to dig into this, if you wanted this whole data frame and you wanted to use it for your, in your project, you could just blow away all of this. So by default, this function gives you all the data. Okay. So here you can see what's in our data frame, right? You can see it has a signed at time, a to and from amount, and a to and from token, and it really helpfully kind of fills in the names of these tokens, as well as the trader, but the trader is always Sovryn protocol. Great, so we have the data. Now let's try to make some sense of it, right? So first of all, if we really wanted to, you could get more information about the various tokens, right? So There's a helpful built-in function that I've written that will let you sort of grab some of these tokens by name. You can see the whole address if you really wanted to go into the weeds. Right. But now let's take this data frame and then we can do something. We'll just do something very simple just to kind of show off, do as a proof of concept. Let's see what the kind of implied exchange rate is between wrapped Bitcoin and USDT. So remember here, we have to and from tokens, all different. They're going to be all different kinds. Let's just pull out the ones that are between Tether and Bitcoin, right? This is the problem that I sort of opened and motivated this talk with. So we'll hit this, and what should happen is that we should get a nice little line graph of the price history, as we've pulled it up between Tether and wrapped Bitcoin. That's great. That's very powerful, right? So, like I said, why do this at all? Why make this at all? And there's really two reasons. The first one is I found it really hard to get data, and now this is really easy to get data. Getting data is as simple as in some cases writing a function if I've already supported it, and in other cases you have to write a site, a Neo4j database query. And that's fine but now you can get the data as a data frame where you can really manipulate it. And the second one was I wanted to understand the Sovryn protocol in a lot more depth, and I want to help other people who might be coming at this like I was, trying to make sense of the data in the block explorer and seeing it's very difficult just from reading Solidity smart code and looking at block explorer. It's very difficult to piece together how everything works, and I feel like this visualization helps a lot. So if you do happen to be a graph database nerd, maybe you were wondering what the schema looks like. And the schema for this is actually very simple. It's kind of elegant because you can get a lot of complexity. You can capture some very nice complex behavior of the RSK blockchain with a very simple schema. So you have blocks, right? So one node type is a block, and they are chained together, just like you would expect. So there's one block, each block points to the next block. And for this project, I've only included blocks that have transactions on the Sovryn protocol. So you're not getting all, at the time of recording, like 3.5 whatever million RSK blocks. You are only getting the ones with the Sovryn protocol. Blocks contain transactions. And again, I haven't mapped every transaction on RSK, just the ones that pertain to Sovryn protocol. Transactions optionally have a from address and optionally a to address. And these are addresses. And some addresses are special. So if an address is a known contract, like the Sovryn protocol or like the swap AMM network, right? A contract, and we've sort of created a large, I've pulled this from the wiki, right? If these are contracts or tokens that we know about, then I'll fill that in here, right? So it can be to a contract, to a token, and anything that has it, and then the transactions have, sort of 0 or more log events. And the log events are decoded from the ABIs to the extent that the ABIs are known, so that you can get some that sort of helpful markup, because the log event data can be kind of hard it's not human readable, right? It's very hard to parse. So this is it. 1, 2, 3, 4, 5, 6 different types of nodes, and strictly speaking, the token and the contract are merely for convenience. You don't actually need them. And you can capture the whole RSK chain. It's very cool. All right, so future development. What would I like to be able to do from here? I have shown how to get a swap data frame, the data frame of the swap data, just sort of as a proof of concept. I think it would be really cool to package up more queries that people, to the extent that people find that useful, right? And right now this is on Docker Hub. So if you want to run these queries yourself, you have to set up Docker and you have to pull my container. That's not ideal. That's a little bit of friction. So it would be really nice to be able to offer this as sort of a hosted service so that you could query this database, just as you would any other API. And in that case, this repo would turn into sort of like an SDK, right? Or I would give you a nice interface to that so that you wouldn't have to know Cypher. You could just call some functions. So that's it. I appreciate your time and attention. Thank you so much to the organizers and the really helpful folks on the Discord. So particular shout out to Bitnim, who answered a bunch of my questions. And I will see everybody later. Till next time, stay sovereign.